Okay, chapter 13.2, product of powers property. Okay, so a product is a multiplication. So we're going to be multiplying powers. Okay, so this is supposed to be an arrow. Yes, it's not very good. That's okay though. Alright, so say we have, say like 4 to the second power times 4 to the third power. If we looked at that, the book's going to say you just do 4 to the second power plus the third power, and that equals 4 to the fifth power. But I'd like to explain it to you. I'd like you to understand why that works. And it's this middle step. They're kind of skipping a few things. 4 to the second power is really 4 times 4. That's 4 to the second power. And 4 to the third power is really 4 times 4 times 4. And when we multiply 4 to the second times 4 to the third, it is obviously just 4 to the fifth. And so you don't really have to memorize anything. You just have to understand that when you multiply powers by powers, you add them. The problem is that the base has to be the same. They have to have the same base. You can't do 4 to the second times 3 to the fourth and get 12, which is 4 times 3, to the eighth or something. That's not going to work. Or 4 to the sixth. That's not going to work. Because what we would do is we would look at this, and if we followed the same process up here, that would be 4 times 4, and this would be 3 times 3 times 3 times 3. And we multiply those together. We don't get 4 to something. We don't get 12 to something. We get what we started with, which was 4 to the second power times 3 to the fourth power. We can combine these into 3 to the fourth power, and we can combine these into 4 to the second power, but we can't combine them together. So if we have just an algebra like a, let's make that a look a little more like an a to the m times a to the n, that is equal to a to the m plus n. And that's really all you need to know. That it might not make a lot of sense to you, but if the base is the same, you just keep the base and add the two powers. And you can't add m and m, so you just leave them alone. Alright, so cool. So we're going to just do a couple of examples, and you'll see how easy it is. 2 to the fourth times 2 to the fifth is equal to 2 to the 4 plus 5, which is equal to 2 to the ninth. That's all there is to it. Cool. Let's look at another one. Negative 5. And they've written this out as negative 5 to the sixth. So what really happens is this first negative 5 is kind of like, you could put it in parentheses. It's like to the first times negative 5 to the sixth. So you get negative 5 to the seventh. And it is important that you keep that parenthesis here. We talked about that in the last lesson. If it's not there, you can get some interesting answers, especially if you have an even number here for your power, for your exponent. Alright, good. Now if we just do it with some letters, x to the third power times x to the seventh power is just x to the 10th power, because you've got x to the 3 plus 7, so it ends up being x to the 10th. Great. Awesome. Now the second lesson we need to learn is raising a power to a power. So that's a little different than product of powers. This is a power to a power. Alright, so say we have what we've been doing, 3 to the second times 3 to the third. That becomes 3 to the fifth, because we're adding our exponents. But a power to a power is something where completely different, where we have 3 to the second power and we raise that whole thing to the third power. And that becomes a multiplication problem, because that's the same thing as having 3 to the second times 3 to the second times 3 to the second. See, because it's to the third power, we have 1, 2, 3 of them. So that's the same thing as 3 to the 2 plus 2 plus 2, which is 3 to the sixth. There's 2, 4, 6 of these 3's. If we split them all apart, we'd have 3 times 3, that's this first one, times 3 times 3, that's the second one, times 3 times 3, and if we count up all those 3's, it's to the sixth power. So when we have a power to a power, instead of adding, like we did over here, 3 to the 2 plus 3 to get 3 to the fifth power, we multiply. A power to a power is multiplying. So 4 to the third power to the fifth power is actually going to be 4 to the 15th power, because 3 times 5 is 15. So we can show you real quick what that looks like. This is the example in the book. 3 to the fourth to the third is the same as 3 to the fourth times 3 to the fourth times, that's supposed to be a 4, 3 to the fourth, which is the same thing as 3 to the 4 plus 4 plus 4, which is 3 to the 12th. Okay, so we can skip some of these intermediate places if we start to recognize that 3 to the 4th to the 3rd is 3 to the 12th. Ta-da! Okay, let's try another one. They've got w to the 5th all to the 4th power. So that's same as w to the 5th times w to the 5th 4 times, which is the same as w to the 5 plus 5 plus 5 plus 5, which is the same thing as w to the 20th. And again, you could skip all the way to here by remembering that 5, the fifth power, 4 times. It's like it happens 4 times. It's like adding repeatedly. That's what multiplication is, and since it's powers to a power, that's what happens. You get 4 w to the 20th. Alright, very cool. Raising a product to a power. Okay, let's try something like that. This is an example where they have like 2x to the third. Well, that's the same thing as 2, not 3. 2x times 2x times 2x. Now, we could, if we wanted, we could just split these apart. We could say 2 times 2 times 2 times x times x times x. There's 3 x's and 3 2's. It's all multiplied. Then you could put little dots in between each one of these. And because of the commutative property, you can just switch them up. Which means that we've got 2 to the third power times x to the third power. 2 to the third power actually happens to be 8. So you get 8x to the third power is your final answer. And you've kind of just taken it apart, and then you've put it back together, and then you simplify if you can. Now the book is going to show you one extra step, but I think when you get to this point you don't need that extra step. Let's look at one more. Change the color just for fun. This is x times y all to the second power. So you've got x times y times x times y, because there's 2 of them. 1, 2. If you put those back together, you get x to the second power. You get y to the second power. There's 2 x's and 2 y's. And another way to think about it, this is not how your book shows you, but it's how I learned. You could kind of think of this as x to the first power, y to the first power, all to the second power. And since we multiply an exponent to an exponent, 1 times 2 is x to the second. Y, 1 times 2 is y to the second. And you get right there without having to rearrange, take it all apart, and put it back together. It kind of just depends. Let's do one more just for fun. 5 times, no, boop, boop, 5y all together to the fourth power. So this is like 5 to the first power and y to the first power. So it's like 5 to the fourth power and y to the 4th power. And then you just have to figure out what 5 to the 4th power is. That's 5 times 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. And 125 times 5 would be 500, 625, I believe. Okay, so that'd be 625 y to the 4th. And you kind of have to work your way through it. It takes a little bit of time, but it is certainly possible. Have fun. This is actually a fun assignment.